Hi everyone, welcome back to the Data Guy, your go-to channel for mastering data engineering tools and concepts. If you're new here, I am Vishal and I create videos to help you build a strong foundation in data engineering. In our last video, we explored data transformations in Spark and how to perform joins in PySpark. Today, we are taking it a step further by diving into powerful data transformations that are crucial for processing and analyzing large datasets. Now, by the end of this video, you will learn how to use aggregations to effectively summarize data, leverage window functions to unlock advanced analytics with partitioned operations. So let's get started and transform the way you work with PySpark. So, what exactly are aggregations? Aggregations are operations that combine multiple rows of data into a single result, typically using functions like sum, average, count, mean, and max. They help you extract meaningful insights from your data by summarizing it. Now, for example, if you're working with sales data, you might want to aggregate it to find the total sales per region or the average sales per product. These operations are key when working with large data sets in Spark. Now, let's start with some of the most commonly used aggregation functions in PySpark. Now, you can use this to quickly summarize your data. First one is sum. This function adds up all the values in a column. Average. This calculates the average of a column. Count. This counts the number of rows in a data frame. Mean and max. These functions give you the smallest and the largest values in a column. So here is an example of how you can use these basic aggregation functions. So here we have this sample data frame, and in this example, we are grouping the data by the product column and applying multiple aggregation functions like sum, average, count, mean, max. Now, this gives us a summary of the sales data for each product. Here you can see we applied different aggregations here, and we got this total sales by applying sum, average sales by applying average, total orders by count, mean, and max sales. Now, one important thing to consider when performing aggregations is to how to handle null values. Now, by default, most aggregation functions ignore nulls. But if you want to explicitly handle them, you can use functions like na.fill. You can use it to fill in missing values before performing the aggregations. Like here you can see, this is how you can use na.fill to uh, fill the missing values before performing aggregations. Now, lastly, look at how to perform aggregations across multiple columns. You can aggregate more than one column at a time by using the aggregation function and specifying different aggregations for each time. So, here in this case, we are aggregating both the sales and ID columns, applying different aggregation functions to each. This gives you the flexibility to perform complex summaries of your data. Here you can see we applied a multiple aggregation and we got the total sales and average order ID here. Now let's talk about the difference between groupBy and aggregation. GroupBy, this groups your data based on a column or multiple columns. It's used when you want to apply aggregation function on subsets of your data. Aggregation, this function allows you to apply multiple aggregation function at once after a GroupBy. For example, in the previous code, group by product groups the data by product, and then we apply multiple aggregation functions in the aggregate to call summarize the data. This combination is super powerful because it allows you to aggregate different statistics on the same group of data. Now let's move on to the another advanced and extremely useful concept, window functions. These functions allow you to perform complex operations on a subset of data similar to SQL window functions. Now, what are window functions? Now, unlike regular aggregation function that collapse your data into a single row for each group, window functions allow you to perform calculations across a window of rows while still retaining the original row structure. This is a super useful when you need to calculate things like running totals, the sum of values up to the current row, moving averages, the average of value over a sliding window, ranking, assigning a rank to each row based on some criteria like sales, or scores. Basically, window functions allow you to aggregate data without losing the detail of each row, which gives you a lot of flexibility when working with time series data, rankings, or any other scenario where you need to compare rows. Now, window functions work by defining a window specification. This spec tells Spark how to divide the row into groups called partition, how to order those rows, and how many rows before or after the current row to include in the window. Now, a window function has three key components: partitioning, how the data is divided into groups; ordering, the order in which rows are processed; frame or window specification, the set of rows that define the window for each row. So let's jump into an example to make this clear. Here is a simple example where we calculate the running total of sales for each product over time. So here you can see we have the data frame. This is the data frame here. We define the window spec. We partition it on the product column and ordered by ID. So basically, in this example, we define a window spec that partitions the data by product and orders it by ID. Then for each row, we calculate the running total of sales using the sum function. Now notice how the running total updates as we move down the rows using each product partition. Now this is super useful when you want to keep track of cumulative metrics over time or across categories. Now, window functions are also great for ranking data. Let's say we want to rank product based on their sales. We can do this using the rank function. Here we are ranking each product by its sales in descending order. The rank function assigns a rank to each row based on the sales value. This is useful for leaderboard style rankings or when you need to identify the top performers in your dataset. Here you can see we are ranking product by sales. Here you can see in the output, we have ranked the product by its sales. Now, next, look at how to calculate moving averages. A moving average smooths out fluctuations in data by averaging a set of values over a specified window size. This is a commonly used in time series data to understand trends over time. Now, here is you can see here is how you can calculate a moving average using window functions. Now, here in this example, we define a window that looks at the current row and the two previous rows. The average function calculates the moving average of sales within this window. This is great for something out short-term fluctuations in your data to see long-term trends. Now, another common use of window function is to assign row numbers or dense ranks to your data. Now, row number assigns a unique number to each row within a partition. Dense rank, which is similar to rank, but without gaps in the ranking sequence. Now, here you can see the example. Now, here the row number function assigns a unique row number to each record, and the dense rank function assigns rank without skipping any numbers, even if there are ties in the data. And that's a wrap on window functions in PySpark. We covered a lot today, from calculating running totals and moving averages to ranking and assigning row numbers. Window functions are incredibly powerful when you need to perform complex calculations across a window of rows while keeping the original row level detail. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the Data Guy for more beginner-friendly data engineering content, and share this video with someone who is just starting out. Have questions or ideas for future videos? Drop them in the comments below. I would love to hear from you. Until next time, happy coding.